To multiply rational expressions, I want to first factor the numerator and the denominator of each of those rational expressions so that I can identify and remove any common factors. So I'll start with the numerator of that first rational expression, that 27x cubed minus 343. I first look to see if there's any common factors, any number or variable that will divide into each term. Well, there aren't any. Then I'll count the terms. There are 2 terms. So for 2 terms, I look for difference of perfect squares. It's not that. Or sum and difference of perfect cubes. It is that. This is the difference of perfect cubes. To factor the difference of perfect cubes, I can use the formula a minus b times a square plus ab plus b squared. So the cube root of our first term would be our a. In this case, the cube root of 27x cubed would be 3x. The cube root of our last term would be our b. The cube root of 343 is just 7. So replace a with 3x, b with 7. So then it's a squared. So squaring each term of that, each factor of that 3x, so I'll have 9x squared. Then I'll multiply the a times the b, so 3x times 7, that's plus 21x plus square the b term, square 7. Okay, so the numerator of that first rational expression can be factored into 3x minus 7 times 9x squared plus 21x plus 49. Now the denominator of that first fraction, 3x squared minus 147. We first look to see if there's a common factor. Well, there is. The 3 will divide evenly in each term, so I'll take out a 3. So if I divide 3x squared by 3, I'll just get x squared. Minus 147 divided by 3 is 49. Now I'm left with 2 terms. So I'll check to see if it's the difference of perfect squares or the sum and difference of perfect cubed. Well, it is the difference of perfect squares. So to factor the difference of perfect squares, I use the formula a plus b times a minus b. So in this case, a is the square root of that first term, so a is x. B is the square root of that second term, so b is the square root of 49, or 7. So it'll be a, which is x, plus b, which we said was 7, times a, which is x, minus b, which is 7. So if I bring down that 3 that we took out initially, I have 3 times x plus 7, x minus 7. Now the second rational expression, that 3x plus 21, I see that there's a common factor of 3, so I'll take a 3 out of each. So if I divide 3x by 3, I'll get x. 21 by 3, I get 7. So the numerator of that second rational expression is just 3 times x plus 7. Okay, the denominator of that second fraction, 27x squared plus 63x plus 147. I first look to see if there's a common factor, a number that will divide evenly into each term. Well, a 3 does. A 3 goes evenly into each term. So 27x squared, if I divide that by 3, I'll get 9. I'll bring down the x squared, plus 63x divided by 3, it's 21x, plus 147 divided by 3 is 49. I can't break that 9x squared plus 21x plus 41 down. That 49 down, that won't factor, so I'll just list it. Now if I cancel common factors, let's see, 3 over 3 will cancel. Like x plus 7 over x plus 7 will cancel. And this 9x squared plus 21x plus 49 over 9x squared plus 21x plus 49, that cancels. So I'm left with, in the numerator, 3x minus 7. In the denominator, I have 3 times that quantity, x minus 7.